Okay, we're going to go ahead and start talking about magnetism, and we're going to talk about general characteristics of magnets, magnetic fields, also talk about electromagnetism a little bit. Now, a magnetic pole is one of 2 points, such as the ends of a magnet, that have opposing magnetic qualities. So 2 like poles repel each other, while 2 unlike poles attract each other. So a lot of times bar magnets have the north and south pole on them. So a north and a south will attract, a south and a south will repel, or a north and a north will repel each other, just like opposites attract. You've got pictures at the bottom to also show you and illustrate this idea. Now there are some materials that can actually be made into permanent magnets. For instance, you can take a piece of iron or a piece of cobalt, and you can actually magnetize those metals by simply rubbing it with a magnet, because magnets exert magnetic force on each other. So the magnets also exerted a magnetic force onto the metals, and then once they're magnetized, they also still can feel, and that magnetic force is still exerted on one another. Now, let's talk about magnetic fields. A magnetic field is a region where a magnetic force can be detected, just like an electric field. You don't have to be touching the magnet to feel the strength of the magnetic field. Sometimes when you're holding a magnet, if it's really strong, as you're getting it closer and closer to something that it's attracted to, you can start feel the pull. And that's the magnetic field going ahead and reacting with the other object. Now, magnets repel or attract each other because of the interaction of their magnetic fields. And magnetic field lines also form closed loops. And these are showing you pictures of magnetic field lines. Do you see how they go north to south, right? On the bar magnet, they go north to south. Now, the picture of the Earth, we're fixing to talk about that right now, because the Earth has magnetic fields also. Now, Earth's magnetic field lines run from geographic south to geographic north, okay? So that means that Antarctica, which is our geographic south, is actually the magnetic north. Canada is near, which is our geographic north, is actually the magnetic south. So if you look at this picture, it shows you how the lines run, that they still go from magnetic north to magnetic south. And those are how the magnetic field lines run for the Earth. Now compasses align with the Earth's magnetic field. That's how a compass works. Okay, we've talked about the general characteristics of magnets and magnetic fields. Let's go ahead and finish up with electromagnetism. When a wire carries a strong and steady current, electric current, they're showing you an experiment basically. So when you have a wire that carries a strong and steady current, the compass needles move to align with the magnetic field that's created by the electric current. So what's the most important thing you need to know on this is that you can use electricity to create magnetism. Okay, that's how they're related to one another. Using the right-hand rule, and we'll demonstrate this in class, and it shows you a picture, but if you hold a wire in your right hand and point your thumb in the direction of positive current, the direction that your fingers curl is actually showing you the direction of the magnetic field lines that are created. Now we're going to talk about a few things that actually use electromagnetism, and solenoids are one of those items. Now, bar magnets and solenoids have similar magnetic fields. A solenoid is a coil of wire that has electric current running through it, and it basically creates a magnetic field in the middle of the coils. Now, the strength of a solenoid can be increased by inserting a rod made of a magnetic metal, such as iron, through the center of its coils. You can also increase the strength of a solenoid by increasing the number of coils. Since you're increasing the number of coils, you're increasing the electric current, and that's what helps increase the strength. This device is called an electromagnet because what you're doing is you're using electricity to create a magnetic field. And once you insert that metal rod into the middle of the magnetic field, it becomes magnetized, and this can be used as an electromagnet. The movement of charges, of the electric charges, is what causes the magnetism. And on the left-hand picture, you actually see, and we'll look at this in class, how you can use a nail. If you just wrap a wire around it that is going to have electric current running through it, you can actually magnetize that nail. And on the picture on the right is showing you a large electromagnet. Now, let's talk about a few electromagnetic devices. Electric motors are machines that convert electrical energy into mechanical energy, and they use electromagnetism. That's how electric motors work. And a motor can perform mechanical work when it's attached to an external device. And motors use a commutator to spin in one direction. And so that allows, remember that direct current, that allows the electrons to travel in that one direction and convert the electrical energy into mechanical energy. Now let's talk about galvanometers. These are devices that are used to measure current. So they measure how many amps are flowing. These can be used with other circuit elements to also function as an ammeter or a voltmeter. An ammeter measures current, and then a voltmeter measures voltage, and so it can be used in conjunction with those. Okay, for your summary, I want you to take these three terms, electromagnets, simple motors, permanent magnets, and I would like you to explain to me how they use electricity and magnetism, possibly even how electricity and magnetism are used together in these. So do this for your summary, and I hope you have a great evening, and I'll see you in class.